Hi, this is Mr. Urrego, and now we're going to find rational zeros with imaginary roots, which basically is find all the values that satisfy the function, or the zeros of the function basically. Now again, I'm using my notes. Hopefully I'm going to improve this for the future. For now, we need it right now. So I'm going to have my function, and the question is find all zeros of the function f of x equals x cubed minus 3x squared plus 25x minus 75. Okay, but they're saying given that negative 5i is a zero of the function. So as you can see, I have an imaginary number as a zero of the function. What do I do in this case? Like I put over here, it says all complex zeros occurs in conjugate pairs, which means if you have one root that is x equals negative 5, the pair will be the positive 5i. Again, if one of the roots is negative 5i, then the other root has to be the positive side of the same number, so it's going to be 5i. On the same thought, if one root is 3i, then the other complex conjugate root will be negative 3i. Okay? In our case, we're using the 5i. So again, whenever you have one root of an imaginary number, right away you can get the other one. In our case, we had as original negative 5i. Now we just found that we have x equals 5i. So now we have two roots. What's our next step? Because I found that these are the zeros of the function. Okay, those are the zeros. X equals negative 5 is a 0. Then I need to write that as a factor. Okay, how do I write that as a factor? Basically, I turn this equation, look, x equals negative 5i, and now I'm going to bring everything to one side. So I add 5i on both sides, have 5i on both sides, and I will get on this side 0. On the other side I will have x plus 5, which turns into my factor. So whenever you have a 0, you want to put everything on one side to make it a factor, which is what I just did in this case. Once I have one of the factors, I'll do the same process. With the other root. I have x equals 5i. I want to make it a factor, so I'm going to bring minus 5i both sides. On the right side, I'm going to have 5i minus 5i equals 0. On the left, I'm going to have x minus 5i, and now that turned into my factor. So now I have one factor here, and the x plus 5i, the other factor. I just found my two factors, like I said, x plus 5i and x minus 5i. Now I'm going to bring those two factors, and I'm going to multiply the two factors using FOIL. X plus 5 times x minus 5. I'm going to multiply using FOIL. So x times x squared, x times negative 5i, 5ix. Now I use the second term, 5i times x. Oh, I'm sorry, I made a mistake right there. So I guess I did x times x, which is x squared, and then I did 5i times x, which is going to give me positive 5ix, and then I used the negative here. Negative 5i times x is negative 5ix, and negative 5 times positive 5i is negative 25i squared. Okay, remember, let me erase this thing. I have here negative 25i squared. What's going to happen with that negative 25i squared? comes negative 25, and the I squared turns into negative 1. Okay, so when I multiply those two, I'm going to get positive 25, which is this 25 that I just put over here. The two middle values, they cancel out. So I have x squared plus 25. That will be the answer of doing these two factors. Okay, always the middle factors, these two, they will cancel out. Okay, alright, so let's erase a little bit over here so we can have some kind of order. Now I ended up having x squared plus 25, and that's the product of the two previous zeros. What I'm going to do next is long division. Okay, I bring my original function. Let me pull it up from the top. If you remember, my original function was x cubed minus 3x squared. As we can see here, that's my original function, x cubed minus 3x squared plus 25x minus 75. And I'm going to bring that, let's move this down. I'm going to bring it over here to do long division. I do my original function there, and the product from my two imaginary roots, this product, I'm going to use it to divide. So I'm going to do long division. I'm going to use long division from my original function divided by the product that I just found, which is x squared plus 25. But if you notice, I put a 0x there. How come? Because there's a missing x there, and whenever you're missing, you put a 0 there. Okay, you don't want to have holes, like I said in class. All right. So now let's go to long division real quick. Now I'm doing long division. How do you do long division? You take the first term, x cubed, and you divide it by x squared. Your answer goes on the top. So x cubed divided by x squared is equal to x. You subtract the exponents. Once you have that, you go back, you take that x, and you multiply back every single one of them, and you put the answer right here. That's what I have. X times x squared is x cubed, x times 0x is 0x squared, x times 25 is 25x. When you're doing long division, remember, you are subtracting. So normally I put a parenthesis right there, and I put a minus on the outside, so you know that you're subtracting. Okay, x cubed minus x cubed, they cancel out. Okay, negative 3x squared minus 0x is negative 3x squared. 25x minus 25x is 0x. Once that happens, you bring down your next term, which is negative 75. Now I have negative 3x squared plus 0x minus 75 divided by this. I take the first term, negative 3x squared divided by x squared, and I get negative 3. Let me erase this again. So you have negative 3x squared divided by x squared is equal to negative 3. Now I multiply back. Multiply times this, times that, and those answers are going to be here. Negative 3 times x squared is negative 3x squared. Negative 3 times 0x is 0x. Negative 3 times 25 is negative 75. I just multiply. I need to remember that whenever I'm dividing, okay, I'm going to use parentheses and a minus. So you're going to have negative 3x squared minus negative, that turns into positive, and these two cancel out. 0 minus 0 is 0, negative 75 minus negative 75. Those two, this negative and that negative turns into positive, and they cancel out. So as we can see, everything cancels out, which means my remainder, remember this is your remainder, is equal to 0. If that happens, your answer is a factor of the function, which at the same way you can make it equal into a 0. So you have x minus 3 is a factor, that's your last factor. You make it equal to 0 and you find the value of x, and that's how you solve that's how you find the roots using imaginary roots. Okay, so your answer, your final answer are, this is the given one, x equals negative 5i. This is the one that you said right away. Listen, if I have a negative 5i, then I have to have a positive 5i, which is the complex conjugate. Okay, remember they come in pairs, and then you multiply those two. You got the x squared plus 25. You come over here and you do long division, and your final answer becomes a factor of your answer, and that turns into a 0. So these are the zeros of the function. Okay, have a great day. Review.